Hey there! I'm Chroma, and today I will be teaching you the basics of making a racing game in Unity, or more specifically, getting a player car to drive. We'll create this setup with getting a car to move forward and backwards, turn left and right as a car should, as well as getting the camera to follow behind in a smooth manner. This tutorial assumes a basic understanding of Unity, but should still be pretty simple to follow along. Ready? Let's get started! Starting things off, I've already gone ahead and made a few things to help speed things along. So over in the project window, I have 4 folders here. Materials, that has a car material, a ground material, and a track material for some of the things that we are coloring, just to make them look more artistic and not be all white. We'll get into what this frictionless thing is in just a moment. We have a models folder that has the track that you're currently seeing. I'm not going to get into how I made this track. It was just, I made it in a 3D modeling application called Blender, but this is not the tutorial for that. The scenes folder that should exist by default, and then a scripts folder that has 2 scripts, car drive and camera follow, that at the moment are currently blank, and we'll be filling those out as we go along with making our car work, I suppose. So with that, over in the scene view, we have actually set up some of the things that I just mentioned. So we have our track here with the color, the green track 1, and a ground here, just because, that all has the blue-ish cyan sort of color there. And then as well on our main camera, I've set the background to solid color and just made it a sort of dark black, but not fully black color. Yeah, so with that artistic-y stuff out of the way, let's get into actually making a car that we can get to move. So we're going to start off by, in the hierarchy, going and creating a cube. That will be our car, so we'll go and rename it as such. I'm going to zoom in on it here. I'm going to go and reset the transform real quick, just so it's more in the center of the world. And then I'm going to drag it up a bit, just so it's on top of our track. Ta-da! Alright, so I'll just go up a bit more like that. Okay, so now let's start by stretching it out to look more in a car shape. So over on the scale of the transform, I'm going to set its values to, I'm going to go with 2.5, 0.75, and 4. There we go. So that's more of a car shape, I suppose. Now as well, let's just go and drag the car material onto it just so it looks a bit more fancy. Alright, so now with that out of the way, let's go and actually get this car to move. So like most things that we get to move in Unity, we are going to be using physics to do so. So over on our car, we're going to go to add component. We are going to add a rigid body component. Ta-da! Now, we'll leave all these settings as they are for now, but we'll be coming back to some of them later on. So now, actually, our car has physics. I guess I could just show it off if we go into play mode. Ta-da, our car falls. Kind of slowly, but we'll get into that as well later. Now, one thing I do want to go and take care of before I forget to, before we go into coding, is this frictionless thing here. I want to explain what that is. So all objects in Unity can have certain physics materials applied to them. So if we go on our track, it actually has a mesh collider just so to deal with, just so I didn't have to set up collision for this entire track. Yeah, so there's on any type of collider, there's a certain option here called material that has physics material here, and then we can go into the little dot thing there to be able to select a physics material, and we can see the only one that exists is the one that I created down here called frictionless. So this is how we can basically make things not have friction or have a lot of friction. This is actually, if I click on the material here, this is called a physics material, by the way. So if I go to create, it should be down there, physics material. That is what that is. There are different options here for dynamic friction, static friction, bounciness, friction combined, and bounce combined. So these are the settings that I use to make it almost frictionless. Technically, it's not completely frictionless, but it worked enough to just have it be almost frictionless. Regardless, so yeah, so we want to apply this frictionless material to everything in our scene, and we could do that by going through and selecting every collider and then setting it to frictionless. But a easier way of going about that is if we head up to Edit, then go down to Project Settings, it'll bring up this window. That'll probably start off with being its own window here, but we can just go and dock that over, for example, over here by the inspector. And then we have different panels here. If we go to Physics, or if you're working with a 2D game, you go to Physics 2D, but we are doing a 3D game, so we're not going to do that. Yeah, we have a bunch of options here. One of them specifically is default material that is currently set to none. If we hit the dot icon again, we can then set that to frictionless. So this will then set the default physics material of every object in our scene to this frictionless material. Just kind of speeding things up there. All right, so now with that all said and done, let's go and make our car actually move. So going back to our car, we are going to be creating a script to get it to move. More specifically, this car drive script that I've already made, but nothing's been done to it yet. So let's go and open that up in Visual Studios and start working on it. So in order to get our car to move, first things first, we're going to want to get a reference to that rigid body component that we made to be able to apply forces to it to be able to get it to move. So we are going to type private, if I can hit the right buttons, rigid body, and we're going to call it RB as a shorthand, I suppose. Then over in the start function, we're going to get a reference to that component by typing RB, the name of our variable, equals get component, rigid body, and then some brackets like that. Not like that. I typed one too many. Hold the phone. If I can hit the buttons that I want to hit. There we go. Like so. Then, yeah, so now that I have this with rigid body component, we can now apply forces to it to get it to move. So now over in the update function, I'm going to go and change the word update to fixed update. This will just allow, by using fixed update with physics calculations, it'll allow it to be smoother and just work better, and is generally just the recommended thing to do. So that is what we are going to do. So now to get our car to move, we're going to be using the WASD keys. More specifically, to get it to move forward and backward, you can use the W and S keys. So let's start by getting those inputs. So we're going to type if input.getKey, like that, and then keycode.w, and then this will test whether or not we are currently holding down the W key or not. And then, yeah, if it is, we're going to run all the code inside from this bracket to this bracket. I don't know how beginner or advanced I'm going with this coding part of this tutorial, but I'm going to hopefully assume that you've at least seen some Unity code before. Anyways, so now that we have this, let's move our car. So we are going to move it by going rigid body dot. Now, I think if you've seen my player moving tutorial, we use, I believe, rigid body dot add force. This would generally be what you'd use to get to apply forces to an object to get it to move. However, with our car specifically, we are going to do something slightly different. Dot add relative force, because actually, if I go back to Unity for a second. With the way that we are getting our car to move, we want it to move, if we're hitting W or S, we want it to move forward relative to the way that it's facing. So if I just kind of like turn it and I click this, we want it to, yeah, move forward relative to the way that it's facing. Along this blue axis specifically, which is the forward axis or the Z axis. So if I head back over to Unity, using rigid body add relative force, if we use that forward direction, then we can apply it in that direction no matter which way that we're facing, so that when we turn, we still move forward in the direction that we want to turn. Long story short, so we're going to go rigid body to add force, the vector 3 dot forward, like so. So that will allow our car to move forward. However, we're going to want a speed value of some kind to control the actual speed of our car that we can adjust in the editor for simplicity. So at the top, we're going to make a public float called speed. As well, when we get to turning later on, we're going to need a turn speed, so I'm just going to go ahead and make that right now as well. Ta-da! All right, so that should allow our car to move forward, and then I can do the same thing to move backwards. If I just copy and paste this code, change this to be else if, and then change this to S, and then make I put a negative sign there so that we're moving in the opposite direction if we're hitting the S key. Ta-da! So now if I go into Unity, I believe this should... Oh wait, I have to add the script to the actual player itself. So now, back in Unity, we can just drag our car drive script onto our player car there, and ta-da. And then I can set this speed to something pretty high, like 100 maybe? And then I don't need to bother with the turn speed right now because we haven't done anything with it. So now, if we hit W, we are... Actually, I don't know if this is high enough. I didn't actually, okay, I didn't actually put the speed anywhere. So now down here we want to multiply this by speed and then do the same down here. All right, now back in Unity, this should work, although I don't know if we're just gonna go flying forward. So now, there we go. So now if we are hitting W and S, we are generally moving forward and back. We're a bit slippery, but we'll be dealing with that in just a moment. Yeah, so we got basic movement. Perfect. So now back over in our code, let's make that a bit better. Actually, let's we'll focus on turning first, then we'll get back to making it a bit smoother. So now that we have this movement, let's get the car to turn. And how we're going to do that is first by testing if we're hitting either A or D, which I'm going to just copy this code and put it down here and change this to an A, and then we'll do, no, I'll do D first. Yeah. And then we'll copy it again for the A code. So now to get the car to turn, we're going to add, it's down here, there, add torque to, yeah, be able to get it to turn. That is just, it's equivalent to adding force to get it to move. This will just add a sort of turning force to our car. Now, the direction that we want to add the turning force is, actually, if I go back over to Unity, so we have these different axi, something like that, of being able to turn, the X, Y, and Z. Specifically for our car, we want to turn it along this y-axis because that is the direction that we want our car to turn in. So that is the up axis in Unity. So over back in our code, we're going to want to type vector3.up, like so. And then I'm just going to multiply this by our turn speed right away. Now, one other small thing I will do, that's not completely necessary, but can just make things a bit easier to handle in the editor, is for a lot of these physics values, we need to make them quite high for them to work the way that we want them to. So I'm just going to add a times 10 to the end of all of these numbers, just so that our variables in the inspector don't need to be as gigantic. Yeah, so now I'm also just going to copy this and paste it and make the A part of this code by just making that an A, changing this to an L so we can't try to move in both directions at the same time, I suppose. And then I can just go and put a negative sign right there. So now we should, I'm going to change this to 8 and our turn speed to 4, I believe. And now we should be able to, we still fall quite slowly, but we now are kind of able to turn. Although not completely how we want, but we have basic turning. Now it is getting kind of hard to see where our car is going because our camera is not following along. So now let's take a quick detour away from our car and get the camera to actually follow along with the car, I suppose. So over on our main camera, yeah, we want to basically get it to move so that it is following along with the car. Now, how we are going to go about doing this is first, we are going to make a new empty game object that we're going to call camera pivot, like so. And then we'll just reset its position here. And then we're going to actually make this camera pivot's position the exact same as the player's position. So if I click on the car, its current position is 0, 20, 0. So on the camera pivot, we're going to make it the same. So it's exactly where the car is. Then we're going to select our camera and actually drag it and drop it on our camera pivot so that it becomes a child object of our camera pivot. So now if we move our camera pivot, our camera moves along with it. So now all we need to do is make it so that our camera pivot, if it's on the exact same position as the player, then the main camera will move along with it with the kind of offset. Now, the reason why we don't want to necessarily just parent the main camera to the car is that if we are then like going off of ramps and stuff like we have back here, if we're turning like up and down, then we have the camera turning like that, which may or may not be what you want, but in this case it is not what we want, so that's not what we're going to be doing. Yeah, so now let's through code get this camera pivot to follow along with the car. So to start off, I'm just going to drag this camera follow script onto here, which we haven't made anything with yet, but now we're going to, on this camera follow script, we're going to open it up and then actually code it to work. So to start off here, yeah, we are going to first need a reference to the player to be able to follow behind it. So we are going to make a public reference because we're just going to drag it in. Then we're going to make this a transform variable, and then we're just going to call it player. Ta-da. So now that we have this player reference, in order to get it to follow along behind the player, we're going to type transform.position. That's the position of the thing that this script is on, which in this case will be the camera pivot, equals. Now, we could just say player.position, but then it'll follow along in kind of a snappy manner. If we want it to get to sort of smoothly lag behind the camera, we can do something a bit more fancy, and we can type vector3.lerp, which stands for linear interpolation. So vector3.linear interpolation from this transform.position again to the player's position, and then we need some kind of smoothing value that we're actually just going to make a variable up here, just for more simplicity of having more things to edit in the editor. So we're going to make a float called smoothing, and then we're just going to stick this variable in here. So now this will allow this object that we're currently on to smoothly follow behind this object here. In fact, actually, I guess I can just go and test that out over here. So now over in Unity, we see our smoothing value, which I'm going to set to 0.3. And then the player, we're just going to drag in our car there. Ta-da. So now if I go into play mode, we can see, okay, so first of all, actually, if I go over to the game view, we're going to want to actually set up better so how the camera is looking compared to the player. So we're going to set it to 8, I guess. Yeah, so 8, -14, and then an angle of 20 of how it's looking at the car. I think that should be fine. Yeah, if you want to edit it more, then you can, I suppose. So now you'll notice things are still a bit jittery, but all in all, we are following the player, but we're not spinning to how the car is facing. So we're going to want to fix that as well. So let's go ahead and do that. So okay, a few things, trying to figure out which thing I want to deal with first. So first of all, that jitteriness. How we're going to fix that is by setting this to fixed update like we did with the car drive. Now, usually you save doing physics, or the fixed update thing for physics related things. However, we are moving the car with fixed update. If we're getting the camera to follow along with the player, it's generally a good thing to sort of use the same type of update function. So if we were moving this in update, then we would move this in update, or anything similar to that. So by moving this in fixed update as well, even though it's not technically using physics, it'll just make it not be so jittery like we were just seeing. All right, so now let's get the rotation to match the car as well. And what I mean by that is that, so if we rotate this on the y-axis, then we're going to want to rotate the camera pivot on the y-axis so that we're looking behind the car of whatever direction that we're facing. So down here, what we're going to do is just a very similar thing. We're just going to go transform.rotation. Now this we could also just say is equal to player.rotation, but we're going to do the same linear interpolation sort of thing. However, with rotations, it's a bit different. Instead of vector3.lerp, we're going to go quaternion, which is the thing that a rotation is, equivalent to how a position is a vector 3, and then .slerp, which is spherical interpolation. Or spherical linear, yeah, something like that. Which is basically the same thing, but it works for angles. Or that's what it's mainly meant to be used for, in a spherical fashion. Now, with this, we then can have the same sort of variable. So then we can have transform.rotation and then player.rotation. And then again, we need a smoothing value, which we're going to make another new variable by just copying this one and then pasting it. Then we're going to call rotation smoothing, I guess, or turn smoothing, or whatever you want to call it. The name itself doesn't matter that much. Yeah, now that should get the rotation to follow along with the car's rotation, except there's one other thing that we want to do first, and that is, if we use this as it currently is, we have not yet solved the problem of if the car is rotating on like the X or Z axis, then the camera is going to rotate on the X or Z axis, which again may or may not be what you want, but in this case it's not. We want the X and Z part of the camera's rotation to always be 0, I guess. So let's go ahead and make that be the case. So yeah, so how we are going to do that then is just looking at my notes real quick. Okay, so how we're going to do that is just by taking our transform.rotation and then getting the X part of it and the Y part of it and just setting them to 0 and then leaving the Y part of it as is. So how we are then going to do that is by going transform.rotation is equal to, I'm doing hand motions even though you can't see them. Okay, so we're going to do quaternion.Euler, and doing that, I'll just type this out and then explain it in a second. So new vector 3 0 transform.rotation.Euler angles.y and then 0 again. So this will so if I go back to Unity for a second, if we look over at our transform here, we have this X rotation and Y rotation and and Z rotation. These are called like the Euler angles of the rotation. In the background of Unity, they're stored as a quaternion, which actually has 4 values, and is something more complex than we need to get into today. But the long story short is by getting the Euler angles of the these rotations, and I'm pretty sure I'm pronouncing that right, hopefully so, we can basically, we can then get those 3 values and then set them. So we can then have this part here of this vector 3 being that X component of it, this is the Y part of it, and this is the Z part of it, as we saw in the inspector. So then we can just 0 the X and Y, leave the Y value as is, and then ta-da, we have that Y value exactly how we want it. So now if I go into play mode, oh, actually let me make this rotation smoothing 0.1, I guess, suppose. Now, yeah, there we have it. So we're still super slippery, but we'll be fixing that shortly. So now we have the camera following along with our car, and it rotates after it as well. So perfect. Now let's head back to our car and finish that up. So back in our car drive, one small thing that we do want to take care of as well is that we want to, our car falls very slowly, so we want to go and make it fall faster. Now, one thing that we could do to have that happen is by going to project settings where we were earlier in this tutorial. There's this gravity value here. We could crank that up a lot to make us fall faster. However, this has the drawback of then everything in our game or everything in our scene would also fall faster, which might not be what we want. Might want to have everything fall realistically, but just have the car fall faster. So we're not going to touch this value. We're going to instead just apply a greater force through code to allow our car to fall faster. So, yeah, so down here in Unity, we are going to go if, actually, no, we don't even need an if. We're just going to constantly do this every frame, is that we're just going to apply a downwards force. So we're going to go rigid body dot add force, not torque, add force, and then just vector 3 dot down, that's just in the downwards direction, times, we'll make another variable, I suppose, called gravity multiplier. Yeah, that's exactly what we're going to do. So we're going to make another float similar to the speed and the turn speed. We're going to call it gravity multiplier. And then we're just going to stick that name in here. And then I'm also just going to do adding the times 10, which isn't completely necessary. It just makes the numbers nicer in the inspector. So this will make us fall faster. If I go back into Unity, we can see, ta-da, a new variable that I can set to, I think 5 will work nicely. By us falling faster, not only will we hit the ground faster, but it'll also help us be a little less slippery. However, you may notice that we are still quite slippery. And this is because, if I can hopefully explain this well. So when we are moving forward, as we turn, we still have velocity in the direction that we were previously moving in. So if we want to solve this problem, what we need to make happen is that as we are moving forward, if we turn, we need to basically still only be moving in the direction that we're facing. So if we're looking at, instead of just our velocity, our relative velocity, we need to make any relative velocity in not the direction that we're moving be 0. Hopefully that made sense. We're going to go code it now, and then hopefully it'll make sense there. So how we are going to do this. Another thing I can quickly do before we get into this, just to make this a bit easier to read, because we have quite a lot of code now, I guess, is I can separate some of these individual pieces of code into their own functions. So I can make one called, I was going to type accelerate, but I guess, oh, that's not what I want. Just one called move. I can make another one called turn. And then I can make a third one called fall, I suppose. And then I can just go in, I can copy this code and paste it down here. And I can copy this code and paste it down here. And then I can copy this last bit of code and paste it here. So now we have each of these 3 sets of code that do different things in their own functions, so that they're just might be clearer to read, especially if you don't understand code that much. Or if you're more of a beginner to programming, I guess. So then now from fixed update, we can just type move and then turn. And I don't know if the order of these matter that much. I don't believe so. And then ta-da. So then now it'll call this move code, it'll call the turn code, and then it'll call the fall code down there. Ta-da. Okay, so that's just a small organizational thing. Again, not necessary, but just might make this easier to read. Now, let's get our car to move forward only the way, relative to the way that it's facing, which is what this does, but now we need to, like, get rid of the x component of that relative velocity. Again, hopefully what I'm saying is making sense, but anyways, we're going to just get into it now. So how we're going to do that is we're going to start off by just getting a vector 3, or making a new vector 3 that we're going to call local velocity, and we're going to need to get what that is, velocity. We're going to need to get what this is, and then modify it, and then make that what our velocity is. And then we can do that by going transform dot, we're going to use a function called inverse transform direction, and then in this function we're going to type rigid body dot velocity. RB dot velocity is just going to get our velocity, but we need to make it not the world space velocity, we need to make it the local velocity. So by sticking it in this function, it's basically going to make it local. Yeah, like relative to the way that we're facing is what I mean by that. So once we have that, we want to set the X part of it, because actually if I go back to Unity, so if I click on our car, the X component, nope, not in rotation, in position, the X is this left and right movement. That is relatively what we want to set to 0. The Y doesn't matter because that's just our going up or down. And then the Z going forward, that's exactly what we want to stay as it is. So then we can just go local velocity dot X equals 0. We're just getting rid of that number. And then we want to take this local velocity variable and stick it back into the velocity. And then we want to do the inverse of what we did here and make it go back from being the local to being the world velocity. So we can do that by, first of all, just going velocity, or sorry, RB dot velocity is equal to transform dot just transform direction without the word inverse, and then our local velocity. Ta-da! And now that should, if I head back into Unity, that should, there we go. We can now move. We now are moving more like a car. We're still kind of like a bit bouncy, but that's more so just with the way that the collider is. If the collider of our little box here was more curved on the edges, it would probably just be a little bit better with that. But this works generally for now. Yeah. So now as we turn, we are still only moving forward relative to the way that we're facing. We can also go off ramps and fly off into the distance. However, one small thing with that you may notice is that if we are going up or down, we can kind of just rocket up into the air. So actually, if I go and just rotate the car like this, and then as soon as we go into play mode, I'm holding W, we can just launch into the air, which is not what we want. We want to make sure that, I'll just get rid of that rotation there. We want to make sure that if we're moving, that we are only moving on this like XZ plane, and we don't have any Y movement as a result of our W or S inputs. So we want to go and handle that. One other small thing I'm going to do is over in the rigid body, I said I was going to leave the values as default for now, but one thing I want to do now is just set up the drag from 0 to 1 and the angular drag as well to 1. Will just help us, as we're driving, if we let go of buttons, it'll help us just stop faster, both with our rotation and both with our movement as well. So yeah. Now going back into our code one last time. We're almost done here. I mean, we are basically done. We have a basic car setup, but now we're just giving it a bit more bells and whistles just to make it work a little bit better. So what we're going to want to do is, so we had this vector3.forward that we use as the direction that we are applying force in. We want to basically get this value and then ignore the y component of it. So how we are going to do that is, if I just put a few spaces and then I'm going to get rid of some stuff after it in a moment, we're going to type new vector3 and then vector3.forward. Yeah, vector3.forward dot x 0 vector3.forward dot z, and then I can get rid of this there. So now this is going to, I just missed a comma there. So now this will basically get that vector3.forward thing that we just had before, except it's going to just get the x and the z, and it's going to ignore the y part of it. And then it's going to multiply by speed and multiply it by 10. So now I can then also, I can copy this whole line again, put it down here again, and then make sure to put that negative sign. Actually, I'll put it just at the speed there. Okay, ta-da. So now, yeah, now we should have an ignored y velocity as we are turning like so. And then I should also mention that down here with the turn, because we are just using vector3.up, because it doesn't matter based on our forward direction, that is ignoring the x and z component for us rotating as well. So that's already taken care of down there. And just like that, I can go maximize play here, I guess. Just like that, our car can now move. Huzzah. So we can drive. It's, well, not realistic. It's realistic for a racing game enough, I suppose. And this is just a basic way of getting a car to move. More advanced racing type games will actually have like 4 wheels with their own colliders on it, and then actually having them spin and getting the car to move like that. But I could make a tutorial, a more advanced thing like that one day, but for now we're just staying simple like this. So yeah, I guess that will do it for this tutorial. I hope you found it helpful. If there's any more tutorials that you want to see, please leave them in the comments below. But with all that said and done, thank you all so much for watching, and as always, I'll see you around.